All right, here's 2017 AB number 3. They say the function f is differentiable on the closed interval -6 to 5, satisfies that ordered pair, -2, 7, graph of f prime. The derivative of f is a semicircle and 3 line segments, and there's the picture for it. So for part A, they want you to find the values of f of -6 and f of 5. So they gave me the graph of f prime. I have to find function values of f, so I should anti-derive this. I should work backwards on this one. So the first thing I want to think about is just that fundamental theorem of calculus, and that is f of b equals f of a plus the integral from a to b on f prime of x dx. Now, I know it's not quite exactly it. It's a slightly modified version. Really, it should be f of b minus f of a on that other side, but this is a useful way to write it if you're solving for a function value. So I'm going to use this one. Now, the order pair that they give you, I like to make that x value, -2, I like to make that the a. And then whatever they want me to find, I'll make that the b in my equation. Now, I am going to start with f of 5 first. I know it's backwards, but I think it might be easier on the geometry side of things here. So f of 5 would equal f of -2 plus the integral from -2 to 5 on f prime of x. So basically this function value right here is the starting function value plus the net change, the difference in that, or the accumulation in that for the antiderivative. So f of -2 they gave us, which that's nice. So I'm going to plug in a 7 for that. Plus, I'm going to use a little bit of geometry to figure out what that -2 to 5 business is. So I'm going to partition this up and just see if I can use geometry to find those little area chunks. So the semicircle is 2 pi. It's a pi r squared, radius is 2, and then divide that by 2. And then the area of that triangle, 1/2 base times height, is 3. The 2 pi is below the axis, and I'm moving left to right. So I'm accumulating negative values as I accumulate. Oops, didn't mean to do that. As I accumulate all these values right here, these are all negative values as I move left to right. And so that's why we're going to make that -2 pi, and then plus the 3. So those together is 10 minus 2 pi. So that's the value of f of 5. Now we're going to go ahead and find the value of f of -6. So I'm going to plug that in. I'm still going to use -2 as my a. That's like my stock starting value. And then I'll take -6, plug that in for my b for both of those. And so I still get 7 minus this integral from -6 to -2. Okay, I did switch the bounds on there. Sorry, I should probably point that out. I'm adding them by default here, but if the bounds are going backwards, I like to switch the bound order and just make it a negative in the front. So I can just swap that sign right there if I want to switch the order on those two bounds. So on the f of x dx, I'm finding, once again, an area chunk there. So from -6 to -2, that answer is 4. And so f of -6 is just 3. For part B, they ask on what intervals is f increasing. So if f is increasing, I'm thinking about f prime has to be greater than 0. So I'm thinking about f prime of x where that's greater than 0. So if I look at that graph, that is the graph of f prime. So anywhere where it's above the axis, it's greater than 0. Below the axis, it's less than 0 for f prime. So I just kind of highlighted the chunks that it would be. So those are my zones right there for where f would be increasing. So if I wrote this in an interval, f prime of x greater than 0 on the interval looks like -6 to -2. -6 does give me a value, so that's why I put a square bracket on that first one. And then -2, +2, and 5 all are actually equal 0, so I would not include those on those brackets. So that's where f prime is greater than 0, and that tells me that f is increasing on those intervals. So for me, increase, decrease, I'm a fan of always using soft brackets or open brackets on those, not putting equal signs, because I feel like you have to have some kind of motion through that. All right, for part C, they say find the absolute minimum value of f on that closed interval from -6 to 5. Justify your answer. So absolute max or mins, I would build a table for these. So I would definitely build some kind of max min table with two things. One, the endpoints. Don't forget your endpoints. And the second is your critical numbers. So I always start by putting my endpoints at the start and stop on your f of x function. Absolute max min, we're just using a regular xy table. We're not using the sign chart one. So endpoint 1 is -6, endpoint 2 is 5, and then any critical numbers I find in between, I'll throw those in there. Critical numbers, once again, that's where f prime of x equals 0, and that happens at -2 and +2. So we're doing pretty good on that. I got those two in my table, so I just got to find some function values. The endpoints, they actually already had me find those from part A. So -6, I already found that, f of -6, and f of 5. So I just imported those from part A. So we're good there. The tricky part is how to find those other two. Well, good news is -2 they just gave us, so that was good. But 2 is a little trickier. I have to do pretty much what I did in part A, make 2 my upper bound, and you still using this stock -2 starting value plus my change in my f prime, and that'll equal this f of 2. So f of 2 would equal 7 plus whatever that integral is. So once again, using geometry, and I am just going from -2 to 2 on this. So a little bit of geometry, that would just be that semicircle of 2 pi again. Once again, it's negative because it's below the axis. And so that means 7 minus 2 pi is the value for 2. 7 minus 2 pi is about 1. 10 minus 2 pi is about 4, ballpark. And so the absolute minimum on this one happens at 2. So f of 2 equals 7 minus 2 pi. And for part D, for each f double prime -5 and f double prime 3, they want you to find the value and explain why that explain why that doesn't exist. So I'll start with that f prime double prime of -5 first. And so once again, I'm thinking about the slope of the graph of f prime, f double prime. They give me the graph of f prime, and so if I want to find the derivative of that, the second derivative of f or the first derivative of f prime, that would just be the slope at that ordered pair. So I'm just looking at this ordered pair right here, and I'm just figuring out what the slope is. I just do my rise over my run, and so I went down 2 and then over 4. So I think that f double prime at -5 would just equal -2 over 4. Or -1/2 for the simplified version. A little trickier on the second part, f double prime of 3 is the slope of f prime at x equals 3. So I'm thinking about that point. Well, f prime is a sharp turn or a cusp at that point. So it is not differentiable at that point. I can't find the slope of a tangent line at that sharp turn. There's a couple ways to kind of think about this. One is from the limit approach, and from the limit approach, we're thinking, all right, as we sneak up from the left side and from the right side, the one side limits won't agree. So that's one reason why it wouldn't work. The second reason I think about it is how do you draw the tangent line of that? So if you were to try to draw a tangent line, would you draw a tangent line like this, or would you draw a tangent line like this? So there's multiple ways to draw that tangent line. And so anyways, at those sharp turns, the slope of that is undefined, which means the second derivative, f double prime of 3, would be undefined.